Good morning, dear students. Hope you are doing well. Today I'm going to continue the explanation of Chapter 19, Acids, Bases and Salts. The topic is titration. The objectives that you are going to learn are: the first one is to identify the point in a titration when neutralization will occur. The second objective is to define standard solution. The third objective is to distinguish between equivalence point and end point. Let us begin with the aim of titration. It is to determine the unknown concentration of a solution. So what is titration? It is a process of adding a measured amount of a solution of known concentration to a solution of unknown concentration. The titration that will be considered is acid-base titration. It is by a reaction which is neutralization reaction. Let us recall what is a neutralization reaction. It is a process that occurs whenever an acid reacts with a base in the mole ratios specified by the balanced equation. Observe the setup of titration. List the glassware used in titration. What do we observe here? A burette filled with base of known concentration. As you see, the burette has a stopcock that can be opened to let the solution pass through it, and the flask contains acid of unknown concentration. By titration, its unknown concentration can be determined. So, the purpose or the aim of titration is to determine the unknown concentration of the acid. Now, what are the steps in strong acid, strong base titration? The first step is a measured volume of 10 milliliter of hydrochloric acid solution taken by a 10 milliliter pipette of unknown concentration is added to the flask. This solution that is added into the flask is called analyte. Why it is called analyte? Because we analyze it to determine its concentration. The second step is several drops of an indicator, let's say bromothymol blue, are added to the acid solution while the flask is gently swirled. We observe that the color is yellow. Why it is yellow? Because bromothymol blue gives yellow color in acidic solution. The third step is a burette is placed above the flask and is filled with sodium hydroxide solution of known concentration. What do we call this solution in the burette? We call it titrant. Why it is called titrant? Because it is added to another solution of or because it is a solution of known concentration that is titrated to another solution. Now the fourth step is start titration. How? By adding the base NaOH slowly to the from the burette slowly to the acid HCl while the flask is gently swirled. Now, what do we observe? Adding the base slowly, we observe that the color, a blue color, appears and disappears quickly. Now, when the yellow color changes to green color and persist, what does it mean? It means we reach to neutralization, or the neutralization has occurred. So the fifth step is a change in the color of the solution. Green is the signal that neutralization has occurred. Now the last step, 1 drop in excess of NaOH changes the color to blue. So here at neutralization, the yellow color changes to green. 1 drop in excess of the base, it changes the color to blue. It means the bromothymol blue is changing, or it gives a blue color. So what is a standard solution? This is the second objective. Standard solution is the solution of known concentration. Where do we put it? Usually we put it in the burette. Now the third objective is to distinguish between equivalence point and end point. So what is equivalence point? Equivalence point is the point at which neutralization occurs. So neutralization occurs when the number of moles of hydrogen ions is equal to the number of moles of hydroxide ions. Two things that are equal in value are said to be equivalent. So here in the graph, this graph shows that the equivalence point is taken, or it occurs between strong acid and strong base at pH equal 7. Now, what is the end point? The point at which the indicator changes color is the end point of the titration, when you observe that there is a change in color. Here at the beginning, let's say that you have a green color and it becomes red. Now, let us explain this graph that shows how the pH of a solution changes during the titration of a strong acid HCl with a strong base NaOH. I'm going to ask you questions that through them you can understand the graph well and understand what's going on during titration. So the first question, what is the device used to measure the pH? Think about it. I want you to remember that in the previous lesson we explained two methods to measure the pH. The first method is the indicator that we use it in titration. Now the second method that helps us to draw the graph is a device. What is it? It is pH meter. Now the second question, before starting titration, examine the graph well. What is the pH of the initial acid solution? From where it starts here? So what will be the answer? It is about 1. So is it a low pH or high pH? It is low pH because it is acidic. The acid solution has a pH less than 7. Now the third question. As NaOH is added, why does the pH increase slightly? What will be the answer? Because some acid reacts with the base. Now, number 4, why does the pH increase sharply, as you see here in the graph? Why the pH jump? The answer, the equivalence point for this reaction occurs. Now try to see the pH at equivalence point between strong acid, between the titration of a strong acid with a strong base. At what pH equivalence point occur? It is at 7. Now, what does the solution in the beaker consist of at equivalence point? Think about it. What do we have in the flask at equivalence point? Okay? Or in the beaker? It is salt, NaCl, and water, also with indicator. Now, from where salt comes? It comes from the salt, which is NaCl. The Na plus, it comes from the strong base NaOH. The Cl minus, it comes from the strong acid HCl. Now, number 7, how are the concentration of H plus and the concentration of OH minus related to the equivalence point? So what will be the answer? They are equal. Now, if I ask you, write the equation of titration reaction, do you know how to write it? So what are the reactants? They are HCl solution, aqueous solution, plus NaOH, aqueous solution. What does it give? It gives NaCl aqueous, which is the salt, sodium chloride, plus H2O, the liquid, water liquid. Now, what is the type of this reaction? Let's recall the type of this reaction. What is it? It is double displacement. Is the reaction exothermic or endothermic? So it is exothermic. Now, conclusion of what we explained. If the titration is between first monoprotic acid and monoprotic base, example HCl and NaOH. Now let's recall, what do we mean by monoprotic acid? So it like HCl, it is the acid that consists of one H plus. What is monoprotic base? Similarly, it is the base that consists of one OH minus. Now, at equivalence point, or what did we say in the previous lesson, at neutralization, the mole ratio between the acid solution and the base solution is 1 to 1. So we say here the number of moles of the solute, which is acid HCl, the solute HCl, over 1 is equal to the number of moles of the solute NaOH, which is the base, over 1. Now, as you know, the number of moles of a solute of an acid, let's say, is equal to molarity of the acidic solution times the volume of the acidic solution. And similarly, the number of moles of the solute NaOH, which is the base, is equal to the molarity of the basic solution times the volume of this basic solution. Now the relation between them is MA times VA is equal to MB times VB. Now let's recall also that what do we have here? 1 mole of the acid is required to neutralize 1 mole of the base. So here MAVA equal MBVB. Now if the titration is between diprotic acid and monoprotic base, example H2SO4 and KOH. Let's see here, why do we call H2SO4 diprotic acid? Because it consists of 2H plus, and the KOH is monoprotic base because it consists of 1 OH. Now at equivalence point, we have neutralization occurs. The mole ratio is 1 to 2. What does it mean? It means 1 mole of the acid H2SO4 is needed to or required to neutralize 2 moles of the base KOH. So the relation here is Na over 1 equal Nb over 2. Now this relation we can substitute it by Ma times Va over 1 equal Mb times Vb over 2, or we can simplify it here by crisscross, and what do you get? 2 times a molarity of the acidic solution times the volume of the acidic solution equal the molarity of the basic solution times the volume of the basic solution. So here, if you have one of these four unknown, we can find it by using this relation. Now let's take a third titration where we have triprotic acid and diprotic base. Example of triprotic acid is H3PO4. As you see here, the hydrogen is 3 hydrogen, or it consists of 3H plus. Diprotic base, it means here the calcium hydroxide has 2OH minus, or when it is ionized in water, it gives 2OH minus. Now, at equivalence point, where neutralization occurs, the mole fraction will be 2 to 3. What does it mean, 2 to 3? It means 2 moles of the acid are needed to neutralize 3 moles of the base. So the relation will be Na over 2 equal Nb over 3. Or we can say here that instead of the Na, or the number of moles of the acid, we can substitute it by 3 Ma times Va, which is equal to 2 times the molarity of the basic solution times the volume of the basic solution. So in this case, we can determine any one of these four by, if we have the others, by this relation. To understand it more, let's take an application. The application here is a 25 milliliter solution of sulfuric acid H2SO4 is neutralized by 18 milliliter of 1.0 molar NaOH, sodium hydroxide. If you observe these two well, the acid and the base, what do we call the acid here? It is diprotic acid. What do you call the base here? It is monoprotic base. Now the question is, what is the concentration of H2SO4 solution? To solve this exercise, let's write first the given and arrange it in this way. H2SO4, it has a volume Va of the solution 25 milliliter. The question here is to find the molarity of the acid by having here also the sodium hydroxide. Its volume, the volume of the solution is 18 milliliter, and the molarity of this basic solution is 1.0 molar. Now we can write the equation. The equation is sulfuric acid H2SO4 plus 2 NaOH, that gives Na2SO4 plus 2H2O. Now the relation at equivalence point, we have here mole ratio is 1 to 2. What does it mean? 1 mole of the acid is required to neutralize 2 moles of the base. So the Na over 1, which is the number of moles of the solute of the acid H2SO4 over 1, equal Nb, which is the number of moles of the solute NaOH over 2. Now the relation is 2MaVa equal to the Mb times Vb. And you can get here Ma is equal to the molarity of the base times the volume of the basic solution over 2 times the volume of the acidic solution. Now substitute by using the values, the numbers, 18 times 1.0 over 2 times 25. The answer will be 0.36 molar. Finally, I hope that all of you found interest in the lesson. Thank you.